ChargerLAB introduced the EHOM EP1650 portable power station before. Its battery capacity is 1024 Wh and the weight is about 13.7 kilograms. It can output up to 1650 watts. The peak output power is 2007 watts, which is pure sine wave output. It has a matte one-piece shell, and the color of it is gray and white. The shell can protect it from dropping from a height of even 1 meter. The front of it is equipped with an LCD, a car port, 5 USB ports, 3 ACL lights, and a light. In addition to the main power bottom, it is also equipped with independent switch bottoms for the DC and AC modules. Each bottom is equipped with an indicator light that lights up when turned on. After powering on, the LCD will display the remaining power, input and output power, and available time. The DC module is equipped with 2 100 watts USB-C ports, 3 18 watts USB-A ports, and a 12 volt 8 amp car port. The ACL light can provide a voltage of 220 watts AC with a rated power of 1650 watts and a peak output power of up to 2700 watts. The car port has a rubber dust plug for protection. The LED light has an independent bottom which can be turned on with one click. Press and hold the bottom for 2 to 3 seconds to enter SOS mode, and click again to turn off the light. There is a hidden cover on the back. The tiny handle on the cover is convenient for users to open. There's an AC input socket, an overload protector, and a DC input socket inside the cover. And some specs info are pasted below the cover. Model is EP1650-3. The battery capacity is 1024 Wh. The battery type is LFP. The discharging temperature is -10 to 40 degrees Celsius. The charging temperature is 0 to 40 degrees Celsius. 2 handles on both sides of the top make it easier for users to carry. It is symmetrical on the 2 sides. It is equipped with high-speed cooling fans and ventilation for heat dissipation. There are rubber covers on the 4 corners of the bottom to provide sliding. Its size is about 34 by 26 by 26 cm, and the weight is about 13.7 kilograms. ChargerLAB PowerZ CAM003C shows the USB-A can support FCP, ICP, UFC, QT3.0, SFCP, PE2.0, DCP, Samsung 2 amp, and Apple 2.4 amp charging protocols. The test results of the 3 USB-A ports are the same. ChargerLAB PowerZ CAM003C shows the first USB-C port can support FCP, ICP, EFC, QT3.0, QT5, SFCP, PE2.0, PD3.0, PPS, DCP, Samsung 2 amp, and Apple 2.4 amp charging protocols. And it has 5 fixed PDOs of 5 volts, 9 volts, 12 volts, 15 volts, 3 amp, and 20 volts, 5 amp, and a set of PPS. The supported protocol of the other USB-C is the same as the first USB-C port. So as the PDOs. The 5 USB ports have good compatibility. Next, let's start to take it apart. First, remove the side bracket fixed back clips. Unscrew the screws and remove the set cover. The battery pack and cooling fans are fixed inside the case. Remove the other side bracket. This side also has a battery pack and cooling fan. The cooling fan is fixed with screws. Unscrew the fixing screws on both sides of the case. Take out the battery pack and bidirectional inverter module from the case. The wire passes through the magnetic ring to express high-efficiency inverter series. The input protection PCB and the fast charging output PCB are fixed on the case. There are resistor, safety active capacitor, and common mode choke on the AC input protection PCB and EMI PCB. The input socket is connected via the connector. The filter inductor is fixed with zip ties. The all-out protector is from Agent. W55-128 will replace it in the official version. Remove the input protection PCB. There are resistor, safety axle capacitor, and common motor choke on it. And there are no components on the back. The AC input is connected via bending posts. The input fuse is insulated by heat shrinkable tubing. The resistor is from STE. These two blowback capacitors are also from STE. The safety axle capacitor is from Sincerity, 1 microfarad. These two common motor chokes and safety axle capacitors are fixed with glue. The common motor chokes are wound with magnetic rings. The other safety axle capacitor is all from Sincerity, 1 microfarad. The DC input PCB is equipped with an XT60 connector. There are no components on the back. These two Schottky diodes are connected in parallel to protect reverse connection of the DC input. They adopt DO-277 package, 10 amp, 60 volts. There are PCBs of AC outlets and fast charging on the other side of the case, and the light bar is fixed with screws. The AC output is connected to the binding posts via screws. The socket of the car charger is connected by an XT60 connector. The thermistor is fixed on a heatsink. The connecting wires are protected by the magnetic ring to suppress interference. The AC outlets are soldered to the PCB, and the bending posts are on the right side. There are openings of the USB ports and the blue buttons. There are 18 LED lamp beads on the LED bar. The socket is soldered on the back of the LED bar. The MCU, wireless communication module, buck inductor, and USB sockets are on the front of the fast charging PCB. There are two heatsinks and buck inductors on the back. Both heatsinks are equipped with thermometers to detect temperature raise. The fuse marked with 477 is from battery fuse, 20 amp. There are two diodes to provide reverse flow. The fuse marked with 477 is from battery fuse, 20 amp. The TVS marked with C70 is used for overvoltage protection. These two MOSFETs are used for power supply control. There are two diodes to provide reverse flow. One of the synchronous buck boost chips is from Renesas. It supports a working voltage of 60 volts and is used to charge the built-in battery. These four MOSFETs of the synchronous buck boost chip are from PC Semic. The other synchronous buck boost chip is also from Renesas. It is used for buck control. Here are the two buck MOSFETs. The heatsink for the MOSFETs have a thermistor on the side. These two inductors are wound with magnetic rings and they are also insulated with bakelite. These two electrolytic capacitors for input filtering are from Caption, 100 microfarad, 100 volts. The other electrolytic capacitor has the same specifications. The solid capacitor is from Wiener, 100 microfarad, 100 volts. There is another solid capacitor, 220 microfarad, 35 volts. The MCU is from GigaDevic. Its frequency carries 120 MHz. It has a built-in Cortex M4 core with 224 KB flash and 48 KB RAM. This is the 8 MHz crystal oscillator. The buck chip is marked with A6163K. Here is the SMD buck inductor, 50 microhenries. The wireless communication module is from Expressive. These two chips for transceivers are from Moansan. They are used for RS485 communication to communicate with the battery pack. The 8-channel switch used for signal acquisition switching is from RIC. The op-amp used for signal acquisition and amplification is from RIC. Both two buck controllers of the two USB-C ports are from iSmartWire. They support charging of any USB-C and USB ports and dual-port independent current limiting, and they can output up to PD 100 watts. There are two synchronous buck MOSFETs. The heatsink of the buck inductor is glued down. The sample resistor is used to detect the output current, 5 kilo. There are two TVS between the two USB-C sockets for electrostatic protection. The buck controller of the three USB-A ports is also from iSmartWire. It integrates a 3.5 amp high-efficiency synchronous rectifier buck converter. It supports CC and CV modes and multiple charging protocols. Here is the buck inductor, 22 microhenries. The TVS is used for overvoltage protection. The synchronous buck controller of the carport is from Renesas. It supports a working voltage of 40 volts. There are two buck MOSFETs. The heatsink of the buck inductor is glued down. There is a button next to the buck inductor for DC output control. And there is an LED indicator light on the right side to indicate the output status. The buck chip is from silicon. It integrates MOSFET inside. It supports 5.5 to 100 volts input voltage and 2 amp output current. There is the buck inductor, 47 microhenry. The back of the synchronous buck MOSFET is covered with a large heatsink. The buzzer is used for reminder. The LCD is soldered on the front of the display module. The driver chip and socket are on the back of the display module. The driver chip is from Ichor. Unscrew the screws and open the bidirectional inverter module casing. The fans are connected with these connectors. The PCB of the inverter module is fixed inside the casing with screws. The components are filled with spawning compound. The fan is from Renda, 12 volts, 0.26 amp. Separate the battery pack and the bidirectional inverter module. There are capacitors, MOSFETs, and transformers on the front of the PCB module. 2 MCUs are on the back of the PCB module for primary and secondary control respectively. The MOSFETs corresponding to the primary and secondary sides are driven by isolated drivers. The MCU used for DC side control comes from Giga device. Its frequency can reach 120 MHz. It has a built-in Cortex-M4 core with 512 KB flash and 66 KB RAM. This is the 8 MHz crystal oscillator. The MCU for AC control is the same as the previous one. This is another 8 MHz crystal oscillator. The 3 digital isolators used between 2 MCUs are from Novisense. The 6 isolation drivers corresponding to the MOSFETs are also from Novisense. This is the fuse of the DC side, 100 amp. The sampling register is used to detect DC, 0.5 mA. These 5 electrolytic capacitors for input filtering from Caption are connected in parallel. 1000 microfarad, 63 volts. This is the buck circuit at the input end. The buck chip is from silicon. It is used to power the driver. These 2 primary MOSFETs are from PC Semic. There are insulating pipes between them and the heatsink. The other 2 MOSFETs have the same model. The magnetic core of the transformer is insulated by tape. The magnetic core of the resonant inductor is also insulated by tape. The filter capacitors are from Caption. There are heatsinks on both sides of the filter capacitors, and the heatsink is also equipped with a thermistor for temperature detection. 330 microfarad, 500 volts. These 4 MOSFETs fixed on the heatsink are from PC Semic. 2 on the left are marked with GEANGFD. The 2 on the right are printed with RBANGFD. There are also 4 MOSFETs on the other heatsink. This is the cement resistor, 100 ohm. The relay is from Songchuan. The contact capacity is 12 amp and the coil voltage is 12 volt. The second relay is also from Songchuan. The contact capacity is 70 amp and the coil voltage is 12 volt. The third relay is also from Songchuan. The contact capacity is 60 amp and the coil voltage is 12 volt. The blue watt capacitor is from STE. The current sensor is from Sanomax, 20 amp. The specification of the filter capacitor is 220 microfarad, 35 volts. The safety X capacitor is from Sincerity, 1 microfarad. Take apart the case of the battery pack. The battery pack and the bidirectional inverter module are insulated by Mylar sheets. The positive and negative poles are connected to the PCB of the bidirectional inverter module through the bending posts of the battery pack. The battery protection PCB is fixed on the upper cover. The battery pack and the PCB are connected through wires. There are connectors on the PCB on the side of the battery pack. The batteries are fixed with an insulating frame. 8 batteries make up a set, and there are 2 sets of batteries in series. The battery packs are connected through copper sheets. There are PCBs on both sides of the battery pack for voltage detection. The PCB is connected to the voltage sampling point of the battery pack. The batteries are held in plastic frames. The battery is from EVE, 20 mAh, 3.2 volts, 64 Wh. There are MOSFET, fuse, and resistor on the battery protection PCB. And there are TVS, battery protection chip, and MCU on the back. The battery protection chip is from STandalone. It has overcharge, over-discharge, temperature, and other protection functions. These 10 battery protection MOSFETs are from PCSemic and adopts TOLL-1L package, 80 volts, 1.6 mA. Two sampling resistors used for detecting the currents of the battery packs are connected in parallel, 0.3 mA. The MCU is from Giga device. Its frequency can reach 120 MHz. It has a built-in Cortex-M4 core with 224 KB flash and 48 KB RAM. It also supports PWM signal output. This is the 8 MHz crystal oscillator. This is a 32.768 kHz crystal oscillator. The memory chip is from Berlin. The capacity is 256 KB. The buck chip is from MPS. It supports an input voltage of 100 volts and an output current of 3.5 amp. There is the buck inductor, 33 microhenry. The SMD fuse marked with 491 is from battery fuse. It is used to protect the battery pack from overcurrent, 100 amp. The TVS diodes are used to suppress surge voltage. There is the NTC thermistor on the right side to detect the temperature of the battery protection MOSFET. The TVS diodes marked with C64 are between the positive and negative of the output. The driver used to drive battery protection MOSFETs from Novisense. The driver used for transformer driving is from IXYS. This is the isolation transformer. The regulator chip is from Berlin and adopts TO252 package. The dual voltage comparator is from 3-peak. The dual op-amp is also from 3-peak. The transceiver chip is from Morrison. The TVS is from Bensand. Well, those are all components of the EHOM EP1650 portable power station. After taking it apart, we found it adopts a modular design. The interior is mainly composed of fast charging PCB, bidirectional inverter module, battery protection PCB, and battery pack. It adopts the LFP battery with a capacity of 1024 Wh. It supports a two-way inverter input of 1200 watts and an inverter output of 1650 watts. Each module is connected by connectors and bending posts. Okay, that's all for today's video. Please drop a like, leave a comment, and subscribe to us. See you next time. Bye!